All right, well, thank you. Full warning, my first ever presentation, so like all first things, I will fumble around, I will think I'm doing a good job, and you'll probably leave unsatisfied. So what I'm going to talk about today is bringing JavaScript alive with Johnny Five. So it's just an introduction to the Johnny Five JavaScript IoT library. I am by no way an expert in this, but I want to present to you guys what I've learned. So without further ado, let's get into it. So what I'm going to talk about today is I'm just going to give you guys an overview of the Johnny Five API. We'll look at some code demos. I've bought I've bought an Arduino Mega board, a breadboard, and just some sensors, some LEDs, a relay, and a couple of servos that we'll have a look at. I'll then do a summary, and then I'll leave some question time at the end of the presentation. So my name's Mark Valenzia. I'm a UI UX developer at Siama Research and Development down on West Burleigh. We are a small company that does asset management, and we use drones to actually basically go over the asset, and we provide reports for customers. We're also developing some asset management software with a go live date. We've got UAT testing in Minnesota in the US in January, where it's minus 25. And we're not looking forward to that. But yeah, so that'll be good. I was born in Glenrowan, hence Ned Kelly there. I'm currently building a CNC plasma cutter. Anyone know what a CNC machine is? Yeah, cool. This one uses a plasma torch to go and basically cut steel out and hopefully other things. I'm into hunting, so I'm a bow hunter. I also do long range rifle shooting, and I used to ride my bike, but I also have 3 kids, 5 and under, including twin girls. So we're quite busy at home. Okay, so what is Johnny Five? So Johnny Five is a JavaScript library for robotics and IoT. It works with Arduino. It works really well with Arduino, so Arduino Uno, Nano, and Mega boards. But you can also use it with other compatible sort of boards like the Raspberry Pi, Intel Galileo, BeagleBone, and you use an I/O plugin that you have to bring in to actually interact with the I/O pins. It's a way to interact with different types of sensors and relays and LEDs and so forth using JavaScript. And it was written by, I hope I pronounce it correctly, I think it's Boku back in 2012. So it's been around for a long time. It was written by a guy by the name of Rick Waldron, who's done amazing work on this actual API, and it's basically a community project. So we'll have to have a look at some demo code, because this is going to, I sort of looked at, I didn't want it to sort of be just a theoretical talk. It's IoT, we should have a look at some code and get some things hopefully working. Hopefully there's no white smoke in this presentation. So who knows here what the Hello World equivalent is in IoT?
Blinking LEDs.
Exactly. LED, blinky, that's right, blinky. So what I'm going to do for the first code demo is just going to be, let's blink an LED. Now, I've got it was the biggest LED I could find down here, which is quite big for an LED, and I've got the webcam up, so when we switch to the code view, we'll be able to see that, so you'll see that hopefully up on the screen there. So there are some prerequisites for Johnny Five. Like all JavaScript, you need Node. It's basically, these are what they call Node bots, so it uses the Node runtime. It also, we need NPM, we get that with Node. Arduino Uno, Nano, and Mega are the best to start out with. And it's simply a case of just NPM installing the internet and Johnny Five. You also have to set up your Arduino board to make sure it's running the standard Fermata firmware. So you go to, I've got a link here to the Arduino website. So if you actually jump onto Arduino, you can actually either use the web editor or download the actual software itself, and it will give you an IDE that looks like this. And under File, Examples, we come down to Firmata, and that's the firmware that actually gets installed onto the actual Arduino itself. And we can connect to that using the tools. We come down, we select our board. I've got a Mega, select our port, which we have here, and then you just actually upload the sketch. So that's all you really need to do with Arduino, with the actual Arduino IDEs. Just make sure you've got the correct firmware on your board, because the Johnny Five API does have, with certain boards you will run certain firmware, but the documentation is really good and it tells you which firmware to run. So we'll jump back into the presentation. Oh, not beginning, sorry. Okay, so once we've got our firmware installed, this is a basic Johnny Five, this is the basic Blink program that I'm about to run. So what we do is we're bringing in the Johnny Five library here. We're also creating a new board. We're then using, now the board has, before I go on to, I should have asked this question earlier. Any JavaScript developers here, or anyone use JavaScript? Awesome. Okay, cool. So anyone familiar with jQuery? Yes, cool. All right. Now, so the board has an on method, and the command that we use, or I guess what we're looking for, is the ready command. So when the board is ready, that's when we want to start throwing in a callback function. So here what I'm doing is I'm creating a LED on using the LED method, and we pass in the pin. So on this particular board, or this particular Mega, I have the LED on pin 53. And then what we're doing is we're using a method called blink, and we're going to make it blink every 1,000 milliseconds. Now, you don't have to do the next step down here on the exit method, but what I've found is if you stop the program, the LED keeps blinking, and then you have to unplug the board. So I actually use the on exit command just to make sure that the LED is actually turned off. And I console.log something out to the console itself. So what we'll do is, let's see if, just minimize this, jump over to Blinky. Okay, so what we've got here is just what we saw up on the screen. Can everyone see that okay? Bit bigger, yep. How's that? Yep. All right. So we're requiring the Johnny Five library up here. We're creating a const of board. So we're creating a new Johnny Five board. Now I'm just creating a variable called LED that I can use later on in my function. So what we're going to do is I'm going to make this LED, hopefully, that you can see here in the camera. Can everyone see that? Awesome. And what I'm also going to do is I'm going to inject in the REPL, which is the read evaluation print loop. And what that allows you to do is from the node command, or from the actual command line itself, you can actually control the LED. So it's really good for when you're debugging and that with it. You can actually play around with certain functions on that LED. So I'm passing that in, and then on exit, I'm just going to say, hey, we're done. Turn the LED off. So hopefully, let's have a look. I was doing some testing earlier. Fingers crossed, this will work. So hopefully that LED there should start blinking. And there we go. Yay! Thank you, demo gods. Okay, so we've got our LED blinking. What I'm going to do is, to stop the command, it's just Control-C, Control-C on the Mac. On a Mac too, if you do use a Mac, you need to use the sudo command to interact. Otherwise, you'll get, it doesn't have the level of authorization to actually run some of the commands within Node, so you need to make sure you use sudo. On Windows, you can just run Node. So what I am going to do is, I'm just going to comment out this line here. And I've just got LED on. Now what we're going to use is this thing called the REPL. So I'm going to start this again, and it's just going to turn the light on. Oh, yes, thank you. Funnily enough, I did exactly that while I was practicing this the other day. All right, so save that, let's go. So my LED is on. So from the, I can go my LED dot off command down here in the actual REPL, and we can turn it off. And it also spits out a whole heap of useful information that we can utilize later on, which I can show you how we do that later on. You can also do with blink, so we can go blink, and it will have, it also passes in some defaults. I think this one blinks every, I think it's 500 milliseconds, or probably quicker than that by the looks of that. So from here you can do a lot of debugging within the actual REPL itself. So, which is pretty cool. Okay. So LEDs are fun, good to start out with, but like printing Hello World 1,000 times, it's pretty boring. You want to move on to something, I guess, a little bit more exploratory. So what I've got here is, for the next demo, is I've got an ultrasonic sensor. And sensors in the IoT world is where that's basically IoT, collecting information, passing and pushing information either up to the cloud or to whatever functions or services you may have running. So I have here a ultrasonic sensor. So what it does is an ultrasonic sensor will send out a, it's basically a sound wave that will shoot off, and it will bounce off. It's same premise as sonar. So it'll bounce off items, it will come back, and what it does is, based on that time, it will actually measure that distance. So this particular sensor is what they call an M1240. Have no idea what that means, but basically if you have a look at the schematics of the sensor, it will give you the wiring diagrams that you need to connect up to the sensors. Now I'm not sure, can you guys see that sensor there? So here we have a ground pin, a power pin, and this is my signal pin just here. So what we'll do is we'll see if we can get this to work and read some data. Now what I will do is, here, doing the same sort of thing, we always have to require the Johnny Five library so we can start utilizing it. We always create up a new board. The sensor itself is running off an analog pin, and that's dictated by the schematic that you have a look at with the actual sensor that you're using. So what I'm doing here is I'm creating a new proximity sensor. Now this is all part of the Johnny Five API library, but they also have another API called sensor, which I'll show you next, that you can sort of, it's a lot more flexible. So it's meant for just sensors that they may not have a specific API for. But I did find this one, and you'll probably see here, this is actually for the MB1230. This is a 1240, but the wiring diagram and everything else is pretty much the same. It's just the, I guess the specs around the actual sensor itself. So this one reads a little bit further than the 30, and it has a narrower beam. So we can still use this one. So what I'm going to do is I'm going to use this library. The frequency is basically how many times I want the sensor to actually read data for us. And then, like we had the onReady command with a board, we also have an onData. So when data is streaming in, it will run this callback function here. And what I'm going to do is I'm just going to console.log out this string that's actually just going to have the distance in centimeters. Now this is all part of the API. The API documentation with Johnny Five is excellent, and we can have a look at that a little bit later on. So what we'll do is, I also have another little function that is using onChange. So when there's a change event, then console.log that the object has moved. So, and then again, on exit, we're just going to shut down. So hopefully, fingers crossed again, demo gods, we can, where is it? Get this to run. Now the limit on this particular sensor is, so if I move this around, you can start seeing, if I move this around, that it's basically bouncing off different objects based on where I point it. The limit on it, I think, is 21 centimeters. This one's sitting at 25 or 23, 22. So I can actually use, they utilize a lot of these particular sensors for autonomous cars. So you could have 3 of these. You could have one pointing forward, one slightly out to the left, one to the right, and you could be reading the telemetry that's coming back off these sensors and actually use it to drive your car and avoid obstacles. So these things are really, really handy. So, but what I've got another example of this one that will, I've got an LED connected up here, so I probably should have went through what I've got here. So the Mega here is connected to a breadboard. Now the breadboard themselves is really good when you're prototyping, because you can actually, it's got a power rail on one side that you can plug directly into from the Arduino, and then you can actually use your, if you need to extend particular input pins and so forth, then you can do that. I'll just make sure, I'm not sure if you can, I don't think I can zoom this camera in, but this here is the actual breadboard. So at the moment I've got the sensor connected up into the breadboard and onto the Arduino, and I've actually got this little LED here. Now what I plan on doing is I'm going to run, now I did speak about another API that I could use with this one. So we had the proximity API, this one's the sensor API, and what I'm doing here is I'm just creating a new sensor. The ID is just literally you can set to anything. I'm setting this to ID 1, so if I had multiple sensors, then this would help me to tell which particular sensor is passing or streaming that particular data. I've got my pin to read off, so which is up here again, AO0, and these are all clearly marked on the actual board themselves. And again, frequency of the data read. So at this I'm doing at 50 milliseconds. The default, if I remember correctly, is about 25 milliseconds for most of these sensor devices. And then I've created a new LED, and again, same sort of thing, but this time what I'm using is an inbuilt function called scale, and I'm going to scale the result so that it will change the actual brightness of the LED. Now, when you start changing brightness, it needs to be on a PWM type pin, and what that pin can do is, with a lot of the digital pins and analog pins, it's either on or it's off. But with the PWM, I think that's what they're called, is it can actually change the voltage that's going through that pin, so therefore you can change the brightness of an LED. So hopefully, fingers crossed, if we can get this to run. We'll see if my LED will work. So when it's close, it should be bright, and as it goes further away, it should get dull. Can everyone see that on the screen? Which is pretty cool. So you could use something like this in real world applications as an entry system to a shop front. So you could set something like this so that once the beam's broken, it could tell that someone's walked into a store and set off an alert. If you're out the back of the store, it could pass through that data, whether it's up through to something like Firebase or through to Azure's IoT hub. That could then be let off to alert you out the back that, hey, someone's just walked into my store or walked out of my store. Any questions so far?
That sensor you've got there, that's a single cone?
Good question. Have no idea. I'd have to read the spec. I don't exactly know. Yuke, can you answer that? Don't know. Yuke's my robotics expert at work, so I tend to, Yuki, can you do this? Yuki, can I do this? Yeah, no, sorry.
Usually they have two cones.
Okay.
One is you send a pulse.
Yep.
That'll go out, it'll bounce.
Yep.
And it'll come back and it'll be received by the other cone.
Oh, right.
Hence, you've got minimum 4 pin, plus, minus the trigger.
Yep.
To send the pulse out.
Yep.
And the receiver, which is your data ring, which you connected to A0.
Yep. I think you might. I think that there might be a.
I've never seen them like that with a single.
Yeah, this one.
You've got 3 pin there.
This. Yeah, that's right. So I'm only reading the data. I'm not actually triggering. I believe that this must be a 2-cone then, because it does have a trigger. I think it's the pin just in here. The next one in that actually you can trigger the pulse off, but I haven't I've just sort of been playing around with them. I haven't really sort of investigated or gone further down the route with the actual sensor. I sort of get the sensor going. I'm like, yay, next. Like most front end developers, it's like, oh, next. Okay, so what we'll do is let's go back to our slides. So we've just had a look at some ultrasonic sensor fun, which I think is pretty cool. Now, interacting with the real world is something that obviously IoT is designed for. Now, I've got doing blinky's pretty cool, but wouldn't it be cool if we could maybe blink this lamp? Now, I can do that because I've actually got inside the box here, and I have a what we call a relay. So it's an electronic switch that can turn things on and off programmatically. I have it inside here because this particular light is 240 volt. They give you a relay, say, yep, plug it in here, plug it in here. What they don't tell you is on the back of the relay, they've got the soldering ports, and you don't want to be a switch by touching those. Hence why I've got them in the box. Because yeah, 240 volts, something not to sort of play around with. Now, I've actually split this on the live line. So the live line from this lamp is going into my relay, and then it's coming down to the actual live line to the wall outlet. Now I've got this turned off at the moment, so fingers crossed. I don't want to burn the table. If you see smoke, the exits are here, here, and so hopefully, fingers crossed, we can jump over to my relay example. And the relay's quite simple. Again, I'm just going out to Johnny Five and I'm creating a relay. Johnny Five does all the work for me to create the relay. I have it on pin 22. The relay object has some other data that we can utilize. So for example, I can say, what type of relay are you? And it will return it's either an NC, so a normally closed, or an NO, which is normally open. And what I've done here is when I do my on ready function, I'm going to ask, hey relay, what type are you? And then I'm also going to close it to make sure it's closed. Because at the moment, I believe I have this to normally open, and by default, normally open is the default relay that the relay API will actually take in. And I'm just setting an interval to use the relay's toggle method, which is just going to toggle it off, and I'm going to call that every 1,000 milliseconds. Now, I've also passing in the relay, so I can manually turn it on and off as well from the command line. So let's see. And then at the end of this, most importantly, I'm just making sure the relay's open so that once I exit the board, it turns everything off for me. All right, so fingers crossed, power on. Let's see how we go. Oh, I'm getting some feedback on my servo there by the looks of things. So we've got our relay turning on and off, which is really cool. But we're back to Blinky. So what I did, I've actually written a little node program that will connect to the actual board itself, and I have a web interface where I can actually turn this thing on and off. So, and sorry, just to go back to what I said earlier about me console.logging out what type of, or telling me whether the relay is on or off, it's just spitting out whether it's on or off. So I can actually hit the API and ask the relay, hey relay, are you on or are you off? So we'll just, to anyone there that may have epilepsy, I apologise. So what we'll do is I have a program called server. Where is it? Now this runs up a little node app. It spits it out onto localhost 8081, and if all works, beautiful. So we've connected. I should be able to, let's go here and switch to my light bulb demo. So here's my light bulb, just a very quick interface. At the moment my light's off. In theory, if I hit the on button, this thing should turn on. So what we can do here is I could be out having dinner, picking up the kids, coming home late, grab an app out of my phone, have this up and literally turn the light on inside. Now I know there's light bulbs on the market that are Wi-Fi. I'm getting one from AliExpress hopefully next week, and they've got this type of thing. But this type of thing is cool to build yourself. And I'm also in the process of building a gardening center that has basically it's a water sensor that plugs into the actual dirt and measures the moisture in the soil. And utilizing Johnny Five, that sensor and some servos, I could actually water the garden automatically, or create a web interface like this and literally be anywhere in the world to turn my watering system on and off, or to turn the lights on and off within my house if I need to. So which is pretty cool. So yeah. And we're sort of working on a side project at the moment at work, which is it's actually Yuki over there, who I work with, has some lettuce that he's bought, and it's the most cared for pot of greenery in our entire office. And we're actually going to set up, because we can, an Arduino that'll have a servo that we can remote into, that'll hold basically a jar of water, so we can water the lettuce while over the weekend, so it doesn't wilt. So, but that's that will be coming hopefully soon. So we've looked at some relays. I've got to learn where that goes. Okay, so we've looked at some relays. We've looked at some ultrasonic sensors, some LEDs. We've done some demos. So this is pretty much the end of my talk. It's pretty short and sharp, to the point. Just wanted to sum up basically, or just show everyone what I have learned using Johnny Five. I've got one last actual quick demo, which is this thing here. So if I turn that off and sort of try and move this out of the way. Actually, this is a laser, so I'll probably point it this way. I'll blind myself if I have to. Okay, now what I've got here is I've got two servos. I've got a tilt servo and a pan servo, sorry. I've also got this little joystick. And this is where things start to become a lot cooler. So I'll turn my laser on. That's so we can see it. Okay, and what I'll do is let's run servo. Right. I don't want people in the firing line, so we might just... Come here, Terminator, back this way. All right, so with the control joystick, we can start playing with servos with JavaScript, which is pretty damn cool. The limitation to this at the moment is everything has to be cabled in to do this particular demonstration. But if you're using something like the Raspberry Pi, you can have your Node server running directly on a Raspberry Pi, and you can then communicate wirelessly to it, which is really cool. And that is actually something that we have done at our office, where we have, not as high tech as Sophie, I'll admit, but nonetheless, let's have a look at. So this is what we have currently at work. So this is running off a Raspberry Pi. It runs a relay, and when our build, if we have a build that fails, it lights up the LEDs around our TV, and it's red a lot at the moment, and it will actually list out the build that's broken, and if there's any connection errors or issues. So this one actually just uses the TeamCity API, and it just pings the API every, I think it's every 60 seconds. We just hit the API to see, hey, how's master going on particular builds, which is pretty cool. That actual setup took, probably the soldering of the LEDs was the longest part of it, but the coding side of things took all of probably half an hour. So yeah, really flexible. So back to our slides. Can I present from here? Nope. Oh. Okay, so summing up, Johnny Five is a JavaScript library for robotics and IoT. It's super easy to get started using Arduino. Once you've mastered the API, then you can move to things like the Raspberry Pi. If you've got experience in Raspberry Pi, then by all means go for it. It's simple as just bringing in, you've got to bring in another NPM package called Raspberry, and that's the IO, or that's basically the IO plugin that you need to run the Raspberry Pi. The API documentation, absolutely fantastic, and it can be found at this link here throughout the presentation, johnny5.io. Resources, we have johnny5.io. There is a Gitter channel. The community is really good. If you post a question on Gitter, they will get back to you really quickly. It's quite a massive community, and there's some guys on that Gitter channel that are really quick to respond. So if you have questions getting started, by all means, jump on there and post your question, and they're really good. The Johnny Five library can be found, if you want to go and have a look at it, on GitHub. And there is a Twitter account called NodeBots at the link there, which is really cool. They don't tweet too much, but there's some really good information there. So what's next for me is I've got to figure out how to use this Raspberry Pi. Don't think I'm quite doing it right just yet. The one we have at work I did have some help with, so I think for me and my projects at home, Raspberry Pi is going to be the way to go. Especially the fact that I can connect with it over Wi-Fi. That's a benefit than with the Arduinos. I have read somewhere that there are guys using wireless shields and so forth to get the Arduino up and running, so you can do it via Wi-Fi, and then you can also use a battery source to run these. So you could have a printer case or get a case, waterproof case, and have this sitting outside somewhere, which is something that I'm looking to do with my my actual gardening system at home. Thank you. If you want, I tweet randomly on Twitter. I have a YouTube channel that is documenting my CNC plasma build. I haven't posted there for a while, just got with the kids, it's been a bit hectic. The slides for this demonstration or this presentation can be found at that link there, and the demo code can be found at the demo code link just down there. Any questions? Zen, I knew you'd have a question for me.
Yeah, the question is, sorry, it's not really technical. Is it illegal to do the electrics at home?
If you're not a qualified electrician, I don't recommend doing this. But you can, 12 volt you can. So if you had 12 volt LEDs, then yeah, by all means. Hooking into your mains power at home, you'll need a Sparky for that, unfortunately. Yeah. Any other questions?
I've got lots of fish tank projects for you, Mark.
It's all right. After Christmas. Thank you. Oh, yes?
Do you have something that can push buttons?
I'm pretty sure with some servos and some actuators, we probably could get something that could push a button. Yeah.
It's a comment for the display for the builds. In previous company, we had a noise from Simpson. Super effective.
Oh, really?
Yeah.
Ah, okay. Cool. Awesome. Any other questions?
We'd hate to see you lose interest in Arduino to go to Raspberry Pi. If there's sorts of things that you can't solve, particularly with the wireless.
Oh, yeah. Awesome.
You should.
Yeah, really cool.
No Raspberry Pi, please.
Well, the Raspberry Pi at home, I haven't been able to get to work that well. The one at work, I've done some magic sauce at work that I can't remember off about 14 different forums, and that works for that particular project. But yeah, I've always hit issues with loading Node and NPM, getting the right versions of Node and NPM on the Pi. The Arduino is by far the easiest way to get started. It's really stable, and for anyone starting out.
Can I ask why the big push for Johnny Five?
For me, I'm a JavaScript developer. So for me, it was easy to slip into doing that. I've actually just started playing around with the Windows UWP. If you've got UWP, you can use Windows IoT, and you can load IoT onto Raspberry Pi, and you can do Blinky in Visual Studio, hit run, it pushes it to the Raspberry Pi, and you can start interacting directly with the Raspberry Pi through Visual Studio, which is cool.
Latte Panda?
Oh, Latte Panda? I've heard of the Latte Panda. Yeah, like $140 for this super awesome. Yeah, something like that would be pretty.
If you really want a HD screen and
yes.
you want your USBs already connected, isn't it?
Yeah, and at work we had is it a Pico 880? Is that what we had at work? Which has got an Intel i7 on it. Was it an i7 or something? I think it's like tiny little thing, super fantastic to use once you finally get Windows installed on it. That's the hard part, but once you get it on there, it's a tiny little board, and the guys I think you guys were using it before I started with drones, using it for the drones. So in the business that I work for, they were doing a lot of research and development in custom drone technology as well for their go out and map assets and so forth. So I have all these parts and stuff that I can just play with, which is pretty cool. Any other questions? No? Cool. Awesome. Thank you. Great crowd.